Now the next thing we have to talk about is Descartes' Rule of Signs. If we have a polynomial written in standard form, then the number of positive real solutions is the number of sign changes in the equation, or less by an even number. And the number of negative real solutions is the number of sign changes in the equation f of negative x, or less by a real number. Now f of negative x is just plugging in negative x for x in our polynomial. So let's try this. Here we're given the polynomial f of x is equal to 2x to the fifth minus 3x to the fourth plus 5x cubed plus 12x squared minus x minus 13. And then here we're given the exact same polynomial, but they've just substituted in negative x for us. Well, let's look at our first one and determine how many sign changes we have. Well, here we start with a positive 2. And then we go to a negative 3, so that's one sign change. From a negative 3, we go to a positive 5, so that's our second sign change. From a positive 5 to a positive 12, those have the same sign. A positive 12 to a negative x, that's a sign change. And then negative x to a negative 13, those are the same sign, so that's not a sign change. So we're looking at the positive version of our polynomial, and we have 3 sign changes. That means our solutions will consist of either 3 real numbers, positive real numbers, or less by an even number, so 1 real solution. Now let's look at the negative version. If we simplify this, negative x to the fifth is a negative x to the fifth. So then this would become a negative 2x to the fifth. A negative x to the fourth is just x to the fourth. The fourth gets rid of our negative. So this becomes a negative 3x to the fourth. A negative x cubed is a negative x cubed. So multiply that by 5 and we get a minus 5x cubed. And negative x squared is just x squared. So multiply that by 12 and you have a positive 12x squared. Minus a minus x is a positive x. And then we have a minus 13. So now that we've solved that or simplified it, let's count our sign changes. We have a negative 2 and a negative 3. Those are the same sign. Then we go to a negative 5. Again, that's the same sign. But from a negative 5 to a positive 12, we have one sign change. From a positive 12 to a positive x, those are the same sign, so that's not a sign change. Then a positive x to a negative 13, that would be our second sign change. So, counting those with the negative version of our polynomial, we find out that this original polynomial can have either 2 or less than by an even number, so 0. So it'll have either 2 or 0 real solutions. Now there's 3 possible types of solutions. We can have a positive real solution, we can have a negative real solution, or we can have a solution that's not real at all. So it's imaginary. Well, if we have 3 or 1 positive solutions, and we have 2 or 0 negative real solutions, so we have a 2 or 0, we have to think of all the combinations of solutions we can have. Here we have a 5th power, which means we're going to have 5 solutions. So if we have 3 positive real and 2 negative real, that means we'll have 0 imaginary. If we have 3 positive real and 0 negative real, well, that means we have 2 solutions still to find, so we'll have 2 imaginary solutions. If we only end up with 1 positive real and 2 negative, well, that's only 3 solutions so far, and we need 5, so again we'd have 2 imaginary. And if we only had 1 positive real and 0 negative, then we could have 4 imaginary solutions. Now Descartes hasn't given us any of the solutions for our polynomial. The rule just gives us hints of what our solutions should look like. Now the last thing we're going to discuss is using solutions to build polynomials. Say we're given a bunch of solutions and we wanted to know what the polynomial of those solutions look like. So basically we're taking all the rules that we learned to solve polynomials and we're using them in reverse. Now here we're given the solutions of 1, 4, and a plus or minus 2i. Well, we have 1, 2, 3, and 4 solutions, so we know we're going to have a fourth order polynomial. Now we could have a higher degree polynomial if these solutions repeated, but we're going to assume they don't and just go with a fourth order polynomial. Now how do we get the solution of x is equal to 1? Well, we get that from the polynomial x minus 1, or the binomial x minus 1. Because remember, when we factor something out, each one of those factors is a solution when it equals 0. So if we said x minus 1 is equal to 0, and we solve for x, we'd add 1 to both sides and we get x is equal to 1, which is what we were looking for. So we know x minus 1 is one of our factors of our polynomial. Now we also have a 4 here, so we need to find the factor that when we set it equal to 0 is equal to 4. Well, that's just going to be an x minus 4. If we set x minus 4 equal to 0, and we add 4 to both sides, we'll get x is equal to 4. So x minus 4 then is a factor of our polynomial. Now we're left with this plus or minus 2i. Well, 2i, or I is just the square root of negative 1. We can't actually do the square root of negative 1, so we just call it I. So then this would be 2 times the square root of I, or square root of negative 1. That means x is equal to 2 times the square root of negative 1. And yes, it's a plus or minus, but I'm going to drop that for now, because it'll go away when we square and square root things, which is what we've done here to get 2 square root of negative 1. If I square both sides, I can get rid of that square root sign. And we'll end up with x squared is equal to 2 squared is 4, and the square of the square root of negative 1 is just negative 1. So x squared then is equal to a negative 4, and if we move that back over, add 4, we'll get x squared plus 4 is equal to 0. This x squared plus 4 is what we were looking for. That's our last factor. So now that we have our factors that give us all 4 of our solutions, we just multiply them and get our polynomial. I'm going to start with the first two. X minus 1 times x minus 4. Well, x times x is x squared. X times a minus 4 is a minus 4x. Minus 1 times x is a minus 1x. And minus 1 times a minus 4 is a positive 4. I'm going to combine my like terms. I'm going to get x squared minus 5x plus 4. Then we can't forget this last term. We need to multiply this solution here by x squared plus 4. X squared times x squared is x to the 4th. A minus 5x times x squared is a minus 5x cubed. And 4x times x squared is a 4x squared. Now we got to take care of this 4. X squared times the 4 is a 4x squared. Minus 5x times 4 is a minus 20x. And 4 times 4 is a positive 16. Again, we're going to add our like terms. We don't have any other x to the 4ths. We have a minus 5x cubed. We don't have any other cubed terms, so that's just a minus 5x cubed. We have a 4x squared and a 4x squared. So if we add those coefficients, we get an 8x squared. We have a 20x and a 16. So our polynomial with the solutions of 1, 4, and plus or minus 2i is x to the 4th minus 5x cubed plus 8x squared minus 20x plus 16. And that completes our tutorial on the Fundamental Theorem of Algebra.